Thank you for visiting the BTU website video on our TNT and Pakwash North areas, and thanks to Alan King, our consulting geophysicist, for helping out with this video presentation on some of our results and the interpretive ideas we have based on some of the recent work we've been carrying out. First, let me say that most of what you're going to see here today is interpretive in nature, and most of what we do on an ongoing basis is really vectoring. This means we are constantly reviewing all of the available data sets as we add new pieces of information, always trying to vector in on the highest probability areas for us to find new areas of alteration and mineralization that will hopefully lead to us finding a new deposit of gold and or base metals. Our field crews have spent countless hours in the field collecting reams of data, often at 25 or 50 meter intervals over kilometers of areas, often in conditions that some people would call inhumane. Just think about cold, wet, rain, snow, bugs, and that's just the start. The data they collect is processed and leveled and then synthesized with other data sets and then interpreted using sophisticated data processing programs and comparative modeling. The resultant modeling is the focus of this presentation. Just as a note, this presentation will only show the tip of the iceberg of the complete interpretive package, so keep in mind that we have more information than you will see here today. All of that geological and geophysical data is used when we decide where to drill. Maybe I can start with a brief history of the TNT copper, silver, gold discovery, a bit about Harold Gibson's work from a geological perspective, and then we can have Alan walk us through some of the new work we've completed and some of the new 3D interpretive work he has completed. So the picture on your screen is really a regional magnetic set of data. And right in the middle of that slide, you'll see a significant area of magnetic depletion. And that's what we call the TNT area. We'll get into that in a bit more detail, but just from a regional perspective, to the north of us is the Great Bear property, where they're in the process of doing a huge drill program. They've got brand new discoveries never before seen in Red Lake. And so those are really of interest to us as well. And just in the northeast corner of our property, we've just recently completed about 10 drill holes, and we're waiting for the assays for that project. We've now decided that we're going to take our drill and we're going to go down and test a new target down in the TNT area, and we're going to walk you through some of the information we have and why we think this is a compelling new target. One of the things that we did was we started it with a discovery. I'm not going to say it was by accident. We were actually looking for gold mineralization, but we knew that there was a history of people having found mineralized boulders in this area that have been dragged off by the glaciers, 10,000 years or more ago. And Teck had done some work on that area, but had never really found the bedrock source of those boulders. So our hole 13 intersected some copper silver mineralization. Alan's kind of rotating the screen around a bit, and that line that you see is actually the first line of induced polarization surveying that we did, and it was that little bit of geophysics that brought us to the discovery. Since that discovery, we've drilled a number of different areas. None of the drill holes, the little black lines that you see on your screen, are within 200 meters of any other drill hole. This is still pretty broad exploration work that we're doing. And each of these drill holes was drilled on the basis of either IP data or pulse EM data, or in some cases, I guess maybe a bit of downhole EM data as well. So in the process of doing that, we collected a lot of data. We did a lot of geochemistry. We had Harold Gibson review this from a volcanogenic massive sulfide perspective, and look at all kinds of different correlations between elements and look at this in an alteration perspective. We know that green area in the middle is a strong alteration area. Basically, all of the magnetic minerals have been destroyed. We know that there's strong sericite, carbonate, and in some cases, sodium alteration. Harold's interpretation is that some of the mineralization we found in drill holes like hole 13 and maybe 25, which was drilled kind of at the east end of that IP line, were in fact a footwall alteration to what may be a volcanogenic massive sulfide system. So in the nutshell, what that really means is anything that a lot of the holes that we've drilled are basically drilled in the footwall to what may be a significant alteration package or a significant mineralization package further to the east. We know from our drilling that the dips are generally, the strikes are north-south, and the dips are to the east at something like 50 or 55 degrees. So if you're looking to go up stratigraphy and find mineralization up stratigraphy from that footwall alteration, then you're looking for conductors or mineralization to the east of a lot of the area that we've drilled. So maybe I think we'll change the slide now and get Alan to maybe walk us through some of the interpretive work that we've been doing and that has brought us to the point where we are now.
Yeah, thanks, Bruce. Yeah, it's been a very interesting area. As Bruce pointed out, it started off as mainly a gold program, but once this area, very interesting alteration and base metal mineralization was discovered over here, we've been following it up with a variety of methods, and we were very fortunate in that there's a couple of pre-existing surveys. One is the Separation Lake Mag Survey by the OGS that covers the whole area. And the other one is this, when that's the background here, so it's a huge area, but so we have lots of regional perspective. And you can see how anomalous this mag low here is that defines the TNT area. It really stands out. But then also the colored dots here are airborne EM anomalies from a fairly old airborne geochem airborne EM mag survey that covers the area to the north and to the east and west, and just fortunately came down into the TNT area. And so the first drill holes that encountered the mineralization and alteration in what's become known as the TNT area were up. And then, but as soon as we started getting interesting results out of there, we looked at the available airborne EM map, and you can see that we were seeing weak conductivity associated with the sulfides and alteration in these holes. But we could see that from the mag that the area of that looked like mag due to alteration was quite extensive, a kilometer or so long. And also there was a trend of airborne EM anomalies sitting right on the area that just gradually got better to the south. And actually these are weak to moderate. This is a moderate anomaly out here, and eventually there's some fairly good ones out here. So there was a whole trail of airborne EM anomalies leading into the TNT area. So we've steadily worked our way down here with drilling. And as we were doing the drilling, there was the IP survey was continued down here, and we saw the mineralization in the TNT system all the way down. And then we did surface TEM and also borehole TEM. So from all of those, we were getting weak to moderate conductors and conductors also in the borehole EM. So each one of these colored plates is a conductive sheet that's been interpreted from surface or borehole EM work. And you can see that, again, they are confined to and define the TNT area. And again, the conductivity, which is color-coded by warm colors getting a little bit better, again, steadily increases to the south. So eventually you can see that this moderately good conductor right here was sitting right at the south end of the survey. The regional geochem airborne EM survey stopped here. We did a chrome surface survey that continued that further south. And that picked up two moderate to good conductors shown in yellow right here, which are about 50 Siemens. And the airborne geochem survey actually, with this deep red plate, picked up this whole area as one big broad conductor.
One of the things that we did, this whole project has progressed as time and budgets have allowed, and we had to go and acquire additional pieces of property to carry out some of these surveys. So one of the things that we did was we had a partial line of IP survey that we were unable to complete in the area of hole 33. And so hole 33 was a bit of a geological test. It did intersect some sulfide mineralization, including some chalcopyrite, some copper mineralization. So from that perspective, it was a success. But as we came further south and as we did the pulse EM work, it appears as though there are two, as Alan mentioned, two good targets down there. Hole 33 appears to have colored in front of one of those targets and not to have reached the second target based on what we know about the dips in the area. So hole 33 was good. It was successful, but now we've got a couple of good targets that we're planning to go and test. And they're more conductive than any of the mineralized targets that we saw further to the north. So we're hopeful that some of that's going to be some good copper mineralization, and maybe we'll even see some some good VMS mineralization that could include some zinc. Yeah.
So we're now turning most mag surveys into 3D models using magnetic immersion. It's fairly standard now. And so we inverted a big chunk of the Separation Lake mag survey. You can see that there's a nice hole in the mag. The color indicates magnetic susceptibility. You can see there's an area of very low magnetic susceptibility. Again, coincident with the TNT area. It's very has a very characteristic signature of weak to moderate conductivity, high chargeability, low resistivity, and low mag. So when you can see the airborne anomalies coming down here, and then just right down here, we noticed that in the inversion, there's a little gap between this more magnetic unit sitting stratigraphically above us right here and open to the east. And this was the direction that Harold thought that fluids might be moving from a footwall VMS type scenario here to something maybe higher up in the stratigraphy. So we found it very interesting that the best geothermal anomalies in the area sit right in that gap, and was also relatively untested. The 33 was just to the south of it, a bit over top of the plates. We had the two Krone 50 Siemens conductors down there that were just missed or were just close to 33. And we had this nice little gap in the mag. And we're right under the best geothermal anomalies in the area. So I think it was a natural place for the next hole, and that's where the whole planned hole 66 is going. So once you start looking at the airborne data, you can see that some of the geological vectors indicated that things might get more interesting up stratigraphy to the east. We saw the best conductors in this part of the airborne survey are sitting out under Pakwash Lake. And these get to be moderate good conductors on a slightly different stratigraphic level, but they do seem to have some connections, possible connections from the TNT area up to here. So these were quite interesting. That ground is available to BTU now. And so we've gone out on the lake. The IP lines were continued across the lake. And also we did Krone surface TEM surveys on the lake just before breakup this year. And the results are pretty interesting. We did a inversion of the IP data. So the bright red is high chargeability, and the deep low is low conductivity. So we've got a coincident chargeability, quite strong chargeability anomaly and resistivity low out in the lake there. And we wanted, the IP is good because it confirms that it's not thicker lake sediments. It's also too conductive to be that. So we've got a pretty well-defined target that's got to be something conductive and chargeable out there. So there's the IP, and this is the IP, the volume of the IP data. We ran it from the shore of Pakwash Lake across the lake. This is conductive overburden in the lake. You're seeing it in these weak airborne EM anomalies here. Out in the lake, we see the best quality IP anomalies sitting right out here with high chargeability, low conductivity in blue, and then the TM anomalies. We ran the TM over there too, and the strongest TM anomalies are these pink plates out there. And they're about 30 to 50 Siemens, so within a reasonable range for a zinc-rich pyritic VMS system.
Thanks, Alan. So in summary, we know that we've got at least probably 2 drill targets out under the water on Pakwash Lake. We'll get to those as we're able to figure out the logistics. And then we're actually going to be drilling the 2 targets, the 2 yellow plates back on the shore, starting this week. So we've taken our drill from the northeast corner of the property where we were drill testing gold targets, taken it down, and we're setting up and getting going on that hole. So we expect, with normal drilling problems and production, we should have the results of that drilling in the core box probably in the next couple of weeks for sure.
Yeah, and the intriguing thing about this, when you look at it, starting from the initial intersections of the TNT zone up here, you can see the migration down through here, through the low mag, higher conductivity area. Conductance getting somewhat better here. This area is being tested by drill hole 66, possibly coming out through that gap in the mag into the lake, and then possibly up into this second horizon. And these anomalies are interesting because they're not exactly over this strong TM IP anomaly out here, but these were right at the end of the geothermal lines. The survey stopped right here, and the data was just rising at the end of all these lines. So we didn't know what we were going to get, but I think we've confirmed the existence of that good conductor out in the lake now, and we have a pretty well-defined target out there.
One further point, I think, is that we started that exploring in that area based on looking for gold mineralization. We know that there's good, strong sericite alteration even further to the west out into the granite. And so right from the granite contact and through some of the work that Tech did, and then coming across into the TNT area, we've seen all kinds of good geological environment for gold mineralization. We've seen quartz veins, sericite alteration, green mica, pyrite mineralization, chalcopyrite mineralization. We've had the odd gold hit in there up to 2 grams. And some of the rock units that we're seeing are very reminiscent of some of the rock units that they're seeing up on the on the LP fault area on the Great Bear Ground. So as much as we're really drilling these targets as base metal targets, that doesn't mean that we aren't going to be watching for gold mineralization as well.
Yeah, you'll have to excuse the very fuzzy geology map, but that's the regional OGS map, and you can see the volcanics here, and this is the granites off to the east. So we're just on this, the conductors under Pakwash are right on the edge of the volcanic package as mapped by in the very regional OGS data. And this whole TNT package is a little wedge of volcanics that comes down into the felsic intrusions.
One quick question, Alan. With the targets under Pakwash Lake, with your modeling, how deep do you think they are?
We can pretty well tell, Jamal, from the IP data that we're seeing elevated chargeabilities at N1. So if if we're doing a 50-meter A spacing, even at 2/3 of that, 20, 30 meters, something like that.
Yeah, I would say within 40, 50 meters of the surface. The IP is shallower, probably 50 meters, and the highest conductivity in the deep plates starts somewhat deeper, as it should. And I think they're down about 80 meters. And you can see the IP started about 50 meters. Yeah, so this is a better quality geological map that I finally found. And, the interesting thing about this, there's been a lot of exploration in this area, as Bruce mentioned before, for VMS and gold, lots of interesting boulders and indications. But this remarkable thing, the best anomaly in this whole the survey is these ones on the lake, and they've never been drill tested.
And the work that we've done, the lines of IP that we managed to get in before the ice left the lake this year, and the Pulse EM data indicate that those targets are quite shallow. So once we are able to get out and set up and drill those targets, they're not deep for sure.